You have a SaaS, you're charging people money, and right now, you have no idea if a payment just failed. You don't know if someone canceled their subscription in the last 2 hours. You don't know if you had a churn spike overnight. You find out in the morning, or worse, when a customer emails you. That's the problem. This is cream-worker, an AI agent that watches your cream store for you, 24 hours a day, no dashboards, no manual checks. And here's the part that's a little different. I didn't write this code. 2 AI agents wrote it, for each other, while I watched. Let me show you what that looks like. Creem is a payments platform for indie developers and SaaS builders. Think Stripe, but simpler. Built for small teams and solo founders. They ran a $3,000 bounty. Build an AI agent that monitors a cream store and alerts you when things change. Most people would build a cron job, maybe a webhook listener. We built something different. A full monitoring plugin that uses the heartbeat pattern from Creem's own official spec. It tracks every transaction, every subscription change, and notifies you the moment something goes wrong. And we used it as a test case for something bigger. 2 AI agents building software together. Here's what that looks like in practice. I have the agent running right now. You can see the logs on the left. Every 5 minutes, it checks my Creem store. It fetches transactions, subscriptions, and customer data. It compares that against what it saw last time. Anything that changed, it alerts me. On the right is my Creem test dashboard. I'm going to trigger a failed payment. We're going to watch the agent catch it. Let's go. In the Creem test environment, I can simulate a payment failure. I'm going to find one of my test subscriptions here. Here's a test subscription, currently active. Customer is paying monthly. I'm going to simulate a failed payment. Done. The subscription just moved to past due. Now, instead of waiting 5 minutes for the next scheduled check, I'm going to trigger a heartbeat cycle manually. Watch the output. There it is. The agent detected that subscription moved from active to past due. It knows the customer email. It knows which product. It knows when it happened, and it's already sent me an alert. This is what replaces you checking your dashboard every morning. You don't log in. You don't run queries. You don't refresh the page at 7 a.m. hoping nothing broke overnight. You just get a message. Payment failed. Creem will retry. You might want to reach out. That's it. That's the whole product. Let me show you one more. This one matters a lot for SaaS businesses. Cancellation. I just scheduled this subscription for cancellation. The customer's access will continue until the end of their billing period, but it won't renew. Triggering another check, and there, scheduled cancel detected. The agent tells me the customer, the product, and when access ends. It even adds a note. This might be worth a follow-up if this customer was high value. That's not me writing that. That's the heartbeat pattern from Creem's official spec. The agent knows exactly what to flag and why, because it's following the same playbook Creem designed for AI agents to use. Same logic. Every 5 minutes, every subscription. No humans required. So how does this actually work under the hood? cream-worker has two pieces working together. First, the polling monitor. Every 5 minutes, it fetches your store state from the Creem API, transactions, subscriptions, customers. It compares that snapshot against the previous one. Anything that changed gets flagged. It saves state in a simple JSON file. No database required, no infrastructure to manage. Just a file that persists between checks. Second piece, webhooks. If you want real-time alerts instead of waiting for the next poll cycle, cream-worker also listens for Creem webhooks. A payment fails? You know in seconds, not minutes. Together you get both. Webhooks for speed, polling as the safety net. The code is TypeScript, 0 NPM dependencies, SQLite for history, native Node.js APIs for everything. Open source, fork it, run it, extend it. Here's the part that surprised even me. I didn't write this code. My two AI agents did. Ash designed the architecture, built the plugin skeleton, the alert formatting, the slash commands, the database layer. Then Ash sent the API client and monitor specs to 6, a completely different AI running on a completely different server. No shared memory, no shared context, no Telegram, no copy-pasting code. Just a message. From Ash to 6, build the API client. Here are the endpoint specs and types. 6 received it, built the modules, published them back to Ash's inbox. Ash reviewed 6's code, found bugs in the error handling, pushed back. 6 fixed them. Total time, 12 minutes. And here's what I find genuinely interesting. They disagreed. Ash didn't like 6's original monitor architecture. 6 pushed back on the error handling approach. They went back and forth. They worked it out. No human referee. No me deciding who was right. 2 agents, different servers, 1 code base. We're calling this the Anima Protocol, agent-to-agent coordination over a message bus. This is what powers OpenClaw. Think about what this replaces. You could hire a virtual assistant to check your Creem dashboard every day. Log in, look at transactions, look at subscriptions, send you a summary. That's a few $100s a month. Training time. They forget things, they sleep, they quit. cream-worker is that person, except it costs nothing to run. It never misses a check. It never sleeps, and setup takes about 10 minutes. 1 API key, 1 config block. Restart OpenClaw, done. If you're running a SaaS and you're still manually checking your payment dashboard every day, this is the thing that fixes that. You're not checking. The agent is checking. You just get the alerts that matter. cream-worker is open source and free. Fork it, run it, build on it. If you're building on Creem and you want an agent that watches your store, this is it. And if you want to see more of what happens when AI agents build things together, follow at @GetAskClaw on X. We're figuring out what real multi-agent coordination looks like in production. Thanks for watching.